All right, so today I'm going to be talking about the economy as a network and a set of protocols. So, if an economy is a network, what would be its protocol? We understand at X the economy as a network. This means is a set of protocols plus the participant. And we believe that the answer to this question of what the core protocol of the economy would be is a distributed exchange.
You can't blow them up.
What?
You can't blow 'em
There you go. And what I'm going to do is I'm going to draw you very briefly and skipping some corners into how it is that we can create a logic exchange. This is of a market on a distributed fashion. That means a group of agents that speak the same protocol and that are connected in a network. And this protocol create an emergent exchange where all traders may be able to engage in offers and matches. So in this network, the base agent is a trading agent, and a trading agent just needs two simple um, signals or words. One is publish an offer, the other one match. Whenever it's a matching, the computation, the logic that is executed is a trade. Um, in the case of the distributed exchange, we're going to focus as an entry in a ledger record, whatever it is for simplification. We're going to, for now, leave out where this record is held. What we're going to be focusing is on the semantics of the protocol. So it's a protocol equivalent of a financial asset, and that is how we conceive it, and therefore it has an underlying as opposed to a coin. So the corporation that we're going to go through is the making of an offer and the matching of an offer. And in this case, we're going to exemplify this over a network of two agents. And later on, we're going to show that protocol scales on network of any arbitrary number of agents. So an agent makes an exchange offer. And in the process of exchanging, is basically sending a message to the network. In this case, agent B makes an exchange offer of a token B for a token A that another trader may have an offer for. As the offer traverses the network, the recipient, in this case, agent X, will iterate through its offer queue and try and find a match. If it doesn't find a match, it cannot fulfill it, and the offer will keep propagating to the agents. In this case, agent queues it. What is important to notice in here is that agent Y has its own private state, and it owns and maintains it. Once the agent Y queues it, later agent X may make an exchange offer. In this case, a matching offer of the equivalent amounts. For simplification purposes, we're leaving amounts in here, and we're just assuming that the match is going to be exact, and there's no partial matching, but the partial matching follows the same logic. When the offer in this case is attempting to be matched by comparing it to the offer queue, it does find a match. And in this case, it simply responds with a match message that refers to both offers. Agent X confirms, and the trade is executed. So what we saw right now is the operation that happens usually between one agent, a trading agent, and an exchange occurring between two agents through protocol, in which both have the capacities, the same, are able to speak the same language. So this network, this kind of operation scales from 2 nodes to n nodes. Basically, it's very interesting in the case of it's a distributed protocol with distributed state as opposed to replicated state. So in this case, we're not attempting to create a replicated network with one offer queue in order to match all the offers, but rather we're allowing through protocol the offers to propagate in the network and create a distributed matching algorithm, a distributed matching algorithm across a distributed offer queue. So let's work that. So in this case, obviously the message needs to be sent only to the issuing agent in the network, doesn't need to traverse the whole thing. And this is part of what can be done with social network. Now, if that's the core protocol, just a simple exchange of tokens over a network, how can we expand upon it to create an economy? So the next layer on the stack will be like a specialization of the trading agent into an economic agent. The previous set of slides, we didn't specify where the tokens were being held. In this case, we're going to specify that the economic agent can issue and redeem tokens. So an economic agent has the same capacities of a trading agent, but furthermore, it can issue and redeem tokens. That means it can keep track of its own ledger and its counterparties' ledgers. So in this case, we have an illustration of each other's tokens and issuing each other's offers. So the question to have in mind in here is that is minting a coin is still a valid form of issuance when every agent in the network can issue. So it asks for a different model. So in this case, we borrow from accounting and finance in general, and all holding agents record their tokens as asset in like a balance sheet style assets and liabilities ledger. So once agent asset is the other agent's liability, and all issuing agents record the tokens liabilities. So together they create a distributed data structure. This is to say a distributed ledger. So basically, again, like with the offer queue, instead of creating a central list that will contain all the tokens, each agent is responsible of holding its own records, but at each connection, at each relationship, there's a replicated state for those tokens that are in both sides of the table, the balance sheet. So basically, the replication is done only among the interested and involved parties, and obviously this has the same advantage as the distributed network offer queue. Like any arbitrary number of nodes can fail, and for as long as there's other nodes present, the trades can still occur across those nodes that are still present. We said it offers a different kind of fault tolerance, a different kind of distribution than just brute force global state replication. We call this distributed state. So if we keep building further up the stack, as we build towards the crypto economy as a we define the economic space agent. Economic space agent has the same capacities of an economic agent, but follows a very precise set of protocols that create liquidity, share risk, and create value through the following tokens. The commodity token, the liquidity token, state token. Dick is going to be talking more in detail about these tokens and how they work and the relevance and importance in the design of a crypto economy. For now, suffice to say that this overview is just a simplification of the protocols that will be needed, oversimplification that will be needed to put into practice this crypto economy for time constraints. So mutual credit, again, can be built easily on top of this protocol. In this case, agents can issue and clear credit by issuing tokens denominated in a shared unit account with a parity exchange agreement. Is nothing else, again, that a certain kind of tokens being recorded on economic agents' ledgers, in which, for instance, for credit granting, an exchange offer is made for a commodity token in exchange for a liquidity token. This is the act of issuing credit, basically. And this constitutes payment. Now, as for settlement, we have the credit clearing exchange offer, in which when the economic agent, the flow of goods and services, the flow of commodities goes in the other direction, economic agent B utilizes its liquidity token to get access to the commodity token. This obviously scales with the same properties as the distributed networks we showed before, and liquidity tokens can be exchanged and matched automatically for other liquidity in the network, providing liquidity for systemic liquidity part of the network for as long as there's a mutual credit relationship across any peers connecting the network. So this we see as this is constituting as a payment and settlement protocol for the crypto economy. So the next layer is mutual stake. So basically, the mutual stake is granting an equity stake on the economic output of an economic space agent. It serves as collateral for liquidity tokens and determines the size of the mutual credit line. In this case, again, this mutual stakeholding agreement just creates two records in each other's economic space agents. And through this information, these agents now can engage in a mutual credit agreement up to the amounts defined by those tokens, and while they still keep their stakeholder relationship, therefore creating liquidity. So these are distributed risk-sharing protocols. So together, these protocols may constitute a formal economic grammar, a new economic language. So this is what we're trying to reveal, that the economy is just a set of protocols, and as such can be formalized and implemented in a computational substrate. And hopefully this overview showed that it is possible to formalize these protocols in a way that we have a distributed network topology with a different take on how to create a economic network, a trading network to replication. Dick is going to talk more about the economic rationale of such a design and such a architecture. So thank you for that, and off to you, Dick.
Hey, Jorge, I'm going to ask you one more question there. Like, what are the technological implications or requirements for something like this?
Yes. Okay. So for brevity, so this whole set of protocols are assuming an underlying secure computational substrate. That means there's actually another base protocol underneath. Actually, two. One is base protocol, which is the network programming language upon which these networks can be programmed. And the other one is Gravity and the Gravity protocol, which is the computational substrate that secures, that makes sure that all these transactions are verifiable, that message ordering, it's done for causally dependent computations, distributed computations. And every state change in the network, distributed state change is atomic, it's acid, basically. Atomic, consistent, isolated, and durable. These functions are provided by an underlying which allows us to focus at this layer just on the business logic that is directly applicable to finance and economy.
Good. Hey, thanks, Jorge.